So if we're comparing quantities, it's just like any other number. Writing your greater than, less than, or equal to symbol in between. However, now that we have talked about scientific notation, some numbers may be written in scientific notation. So they will ask you sometimes to compare 35,000. Compare that to 3.5 times 10 to the 5th power. And without knowing what this is, okay, we can't compare them. So I'm going to put a little note right here that says we want to change this, change to standard form. That way you can compare. So change to standard form. So we did a little practice on this on our iExcel accounts the other day. And so this should be pretty easy. This tells us how many times to move the decimal. 5 to the right. 1, 2, 3, 4, 5. Put your decimal and add in your zeros. So your number becomes 350,000. So now you can compare easily 35,000 compared to 350,000. So which symbol goes into my little blank space? Anybody know? Less than. It's the less than sign. The less than, I know it's less than because it looks like an L that kind of got squished. It started out like as an L and it kind of got set on. Okay. Some people just realize that Pac-Man eats the bigger number. Okay. However you want to figure it out, I don't care. The alligator sometimes. You'll call it the alligator. But that is the less than symbol. Okay. Another example. What if I have 520,000 compared to 5.2 times 10 to the 5th? Well, I'm going to put the decimal here just to kind of see it. If I were to put the decimal here and move it 5 spots to the right, 1, 2, 3, 4, 5. Does that end up being the same exact thing?
Yeah.
Yeah. So this one's going to be equal to. And then let me show you one with some negative exponents, because remember, negative exponent means that the number started out very small to start with. So let's compare 1.2 times 10 to the negative 4th compared to decimal 0.00012. So we're comparing these two. First of all, if it's a negative exponent, and I'm moving my decimal back to the left because it needs to be a small number. So I'm going to go 4 spaces. 1, 2, 3, 4. Put my decimal here. So my number becomes decimal 0.00012. And compare that with 4 zeros and then a 1, 2. So, which one is the smaller? Grab one of each of those. Anybody know which one's smaller, the first one or the second one? Which one's smaller?
First one?
First one smaller?
No, I meant
the second one. Why is the second one smaller?
it's got more zeros.
Because it has more zeros, okay? So let's put us a little note here. So the Pac-Man always wants to eat the larger one. So there we go. He's going to eat this one because it's bigger. Let's put us a little star note that says the more zeros it has, the smaller the value. All right. So the more zeros it has, the smaller the value. So Pac-Man's going to eat this one. All right. Let's go ahead and start also multiplying and dividing in scientific notation. Multiplying and dividing. Toby, will you close our door for us? Thank you. Multiplying and dividing. This is where it gets a little ugly. Multiplying and dividing in SciNote, in scientific notation. Here's what your problems are going to look like. 2.12 times 10 to the 3rd, and then multiplied by 3.58 times 10 to the 4th. So your problems are going to look like that, and it wants you to multiply them. So how do you multiply them? Well, when we multiplied earlier in our exponent rules on our pink foldable that we did, what was the rule to, what were you supposed to do to your little exponents here when you multiplied the same base? Yeah, add your exponents. So we're still going to add our exponents because we're still multiplying. Okay, so I'm going to put a little note right here that says add exponents because that still works. What about dividing? What was our rule for dividing? We needed to what? Close that door, Timmer. We needed to subtract. So let's add that in there. Subtract exponents. This is just added to your other. Okay. So you want to add exponents when multiplying, and you want to divide when you're dividing, you want to subtract exponents. So here's what we do. We go ahead and multiply our first numbers. So multiply those. And I'm just going to draw a little note, draw arrows, and say multiply. And you can kind of put that in your notes. That way you know what to do. In your calculators or in your brain, multiply 2.12 times 3.58. Here's what I got when I multiplied that. 7.5896, which is a number between 1 and 10, right? Times 10 to the what power?
12.
Nope.
7.
Yes. Yep, you were multiplying. We want to actually add those exponents, so it's going to be to the 7th power. Okay? So it's really not that difficult. Let's try another one. What if I have 9.72 times 10 to the 12th power divided by 3.19 times 10 to the 6th power. Again, it's a division, so that should remind you what you're supposed to do with your exponents. We said subtract them. So if it's a division problem, take your first digits and divide them. So 9.72 divided by 3.19. I got this. 3.04702219. Whew, that's an ugly number. And then,
Can I go on to the next page and do the dividing one?
yeah. Times 10 to the what power?
6.
Yeah, because you subtract your exponents. 12 minus 6 leaves 6. Okay. All right. Now, these that I just showed you, when we multiplied or divided, they were numbers between 1 and 10 already for us. And that was one of our criteria. That's one of our rules. When you write in scientific notation, the first number you write down has to be a number between 1 and 10. The next examples that I'm getting ready to give you are going to end up different. They're going to be numbers that are not between 1 and 10. And you're going to have to fix them before you go on to the next step, okay? So let's look at this example. And I have to move over to my next page. Here, if I have 6.27 times 10 to the negative 5th, now I'm using a negative exponent, which is okay, divided by 1.9 times 10 to the negative 3rd. Rules still say the same. I want to take this number, divide it by this number. So use your calculators or your brains, however you want to do that. Divided by 1.9. Oh, this one's still going to be pretty, actually.
3.3.
Yeah, this one's going to be pretty. 3.3 times 10 to the what power? Negative 5 minus, I'm going to write that up here, negative 5 minus a negative 3. Be careful, because it's going to be a negative what?
2.
Yeah, it's going to be to the negative 2 power. So that one turned out pretty. I was looking at the wrong problem when I wrote that one down. So that one was still okay. It had ugly looking exponents, but we figured that out. All right, let's try this one. 6.11 times 10 to the 3rd times 9.53 times 10 to the 7th. Now, multiply, because it's a multiplication problem, multiply those numbers. It's going to be an ugly number. 6.11 times 9.53. We got 58.2283 times 10 to the what power? Yes, 10 to the 10th. I can't leave it like this because this number is not a number between 1 and 10. It's a 58. So we have to fix it. Okay? So, we're going to put a few little star notes here. Alright? These right here will come in handy. If you move the decimal left, the exponent gets larger. And then another little note, if you move it, the decimal right, the exponent gets smaller. Okay, so that's going to come in handy when we have to fix some of these problems. So now, if I'm taking this and I have to fix it and make it a number between 1 and 10, I'm going to have to move it one spot to the left. If I moved it to the left, what happens to my exponent? It gets one spot larger. However many spots you have to move it or places, it gets larger. So my new answer is going to be 5.82283 times 10 to the what power?
11.
Perfect. 10 to the 11th power. Okay. Let's try another one. We'll try division. What if I have 2.34 times 10 to the 5th divided by 8.78 times 10 to the 8th power? First thing you want to do is do your actual division of your first two pieces and see what you get. 2.34 divided by 8.78 shows up this 0.2665148 times 10 to the what power? When you're dividing, what are you supposed to do to your exponents? Yes, so 5 take away 8, negative 3. Okay, and I'm not finished with this because this is not a number between 1 and 10. So to make it a number between 1 and 10, how many spaces do I have to move it? One space to the right. If I put it here, it's going to be 2.665148. When I move it to the right, it says here, if I move the decimal to the right, the exponent gets smaller. Be careful because it's a negative 3. So how does the negative 3 get smaller? It becomes a what? Negative 4. Good. I was afraid that some of you might say a negative 2 because you're thinking the digit gets smaller, but the further away from 0 that you get on that negative side, the smaller you get. Okay, so that would be your final answer there. All right, let's try one more of this. And then I want to show you actually, let me go ahead and write this because not all division problems will look like this. Most of your multiplication problems will be like this. Sometimes they won't put the multiplication symbol in between, and that's okay. If they put the parentheses side by side, you still know that that means divide. But some of your division problems may be written like this, or they may write it like a fraction. So let's just look at one like that. If I have 7.2 times 10 to the 4th divided by 9.4 times 10 to the negative 11th. This still is a division problem because this fraction bar means divide. It's just written differently. So I would still go ahead and divide my first two digits, 7.2 divided by 9.4. And I get 0.7659574 times 10 to the, we still have to subtract our exponents. It's going to be 4 minus a negative 11. So be careful with your exponent. What's that going to become?
15.
Yes, a positive 15 according to our rules. And now I'm not finished because this is not a number between 1 and 10. I have to move my decimal one spot to the right to make it 7.659574. If I move it to the right, it says if you move the decimal to the right, the exponent gets smaller. And so instead of a 15, it's going to become a 14. There's your final answer. So this requires a little bit of thought, especially whenever you get your answers to put them in the actual correct scientific notation. Okay? So we're going to practice these and see see what we can do. I feel like it's gonna be okay. If you have trouble, ask for help.